So now let's actually go on and measure the responses of the RLC circuit. So here I have the RLC circuit I was holding before. Here I have my function generator, which provides my sinusoidal input. And finally here I have an oscilloscope where we'll measure the response and compare those to the input signal. So let's hook up the system and start driving with the sinusoidal input. So here's the circuit board where we're going to attach all of our components. So each row of holes here is electrically connected. So notice that the inductor and the capacitor are connected because they each have one leg in the same row. For all of our tests, we will use this inductor, which is of 47 millihenry. In the first experiment, we'll use this capacitor and a 510 ohm resistor, which we're placing here right now. So we hook up the power source, which is the input of our system, and the ground. And here's our series RLC circuit. We now connect the probes to measure the voltage drop across the resistor. So here on the left, we have our function generator, which is providing our sinusoidal input. In the screen, you can see the frequency of the input. If you look on the right, we have the oscilloscope, and the pink curve indicates the input. The red curve corresponds to the output, the voltage drop across the resistor in this case. As I turn on the knob here, the frequency is changing. We're interested in measuring the amplitude of the output, so the amplitude of the red curve here. We'll sweep the frequencies, so we're starting at 100 Hertz, and we see that the amplitude of the response in red is very small compared to the signal, the input signal, which is shown in pink. And as we gradually increase the frequency, the amplitude of the response increases. You see that the amplitude of the pink signal is constant, and eventually the amplitude attains a maximal, and as we increase it further, it starts to decrease again. So we see here that at resonance, the amplitude, the gain is nearly 1, so the response is pretty much the same as the signal. There are just real life issues with the circuit that don't allow us to have exactly 1, but this is pretty close. And now I'll remove the input signal and just explore what happens for very high frequencies. So if I increase the frequency, the signal decreases and eventually tends to 0. The response eventually tends to 0 for very high frequencies.